Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video lesson, I will talk about the topic contact process. In contact process, the conversion of sulfur dioxide into sulfur trioxide is the reversible process and reaches to dynamic state in a closed system. Syllabus learning outcomes are for the 2023 till 25 version for both CIE 5070 and IGCSE 0620. So here are the learning outcomes of this video lesson. State the symbol equation for the conversion of sulfur dioxide to sulfur trioxide in the contact process. State the sources of the sulfur dioxide, burning sulfur ore or sulfur or roasting sulfide ores, and oxygen, air in the contact process. I hope you all know about the ores. Ores are the metal compounds with impurities found in the earth crust. State the typical conditions for the conversion of sulfur dioxide to sulfur trioxide in the contact process as 450 degrees Celsius, 200 kilopascal or 2 atm, and a vanadium 5 oxide catalyst. Explain in terms of rate of reaction and position of equilibrium why the typical conditions state are used in the contact process, including safety, considerations, and economics. This is a simple equation for the for making of sulfur trioxide gas from sulfur dioxide and oxygen gas. You see here that 2 moles of sulfur dioxide reacts with 1 mole of oxygen gas to produce 2 moles of sulfur trioxide gas. Forward reaction is exothermic, so we will write delta H as minus. Sulfur dioxide is obtained by burning sulfur or roasting sulfur ore like zinc plant. The equation will be like this: Z and S. You will write S as state symbol for Z and S. O2 will be written as G because it exists in the gas state. You will get ZnO solid plus SO2 gas. Let's balance the equation. We'll have 2ZnS, 3O2, 2ZnO, and 2SO2 gas. You can also get sulfur dioxide by reacting sulfur solid with oxygen gas to get sulfur dioxide gas. Oxygen is obtained by the fractional distillation of liquid air. Oxygen is obtained by the fractional distillation of liquid air. In this process, air is liquefied first and then slowly warmed. Typical conditions in the contact process: temperature 450 degrees centigrade or Celsius, pressure 2 atm, or 200 kilopascal. Vanadium 5 oxide is the catalyst. 5 oxide V2O5. The reaction is reversible and exothermic. It reaches to dynamic to equilibrium state in a closed system. First, I will talk about the effect of reaction conditions on rate of reaction. High temperature increases the rate of reaction. High temperature increases rate of reaction. This is because particles have more energy, they move faster and collide more frequently. The collisions are more effective. Particles have more energy, and move faster. Change in pressure also has effect on the rate of reaction because there are gases on both sides of the reaction. High pressure decreases the total volume occupied by the particles. High pressure decreases the total volume occupied by the gases. Particles come closer to each other. Particles come closer, having more successful collisions, therefore rate of reaction increases. Catalyst increases the rate of reaction by decreasing the activation energy of the reactant molecules. Rate of reaction by decreasing the activation energy of the reactant particles. Now I will talk about the effect of changing concentration on the position of equilibrium. Increasing the concentration of sulfur dioxide or oxygen or even both will shift the equilibrium to product side. Increasing concentration of SO2 or O2 will shift the equilibrium to product side. The reason is that to decrease the concentration of reactants. To decrease the concentration of reactants, or to increase the concentration of products. Product here. You can even refer the names of reactants and products here. Forward reaction is exothermic, which means backward reaction is endothermic. So we'll write delta H is minus here. And we know that for a reversible reaction at equilibrium with exothermic forward reaction should favor low temperature. But here the temperature of 450 degrees centigrade is preferred. This is because if a temperature drops too low, the rate will decrease. Therefore, 450 degrees centigrade is the temperature compromise. Low temperature decreases the rate of reaction. But you can write that low temperature will shift the equilibrium to right hand of product side. Low temperature shift the equilibrium to product side. Reason will be either forward reaction is exothermic or backward reaction is endothermic. Forward reaction is exothermic, or you can even write backward reaction is endothermic. Now I will talk about the effect of pressure on the equilibrium. Here are only gas molecules on both sides of the equation. You see, these are gas molecules. 2 moles of or molecules of sulfur dioxide gas reacts with 1 mole of oxygen to give 2 moles of sulfur trioxide gas. You can also refer volume of gases instead of moles of molecules. Here, according to the reaction conditions, 2 atm pressure is preferred. This is low pressure. 2 atm is low pressure. Why pressure of 2 atm is preferred? At high pressure, the particles become closer to each other, thus increasing the collision. Therefore, high pressure favors forward reaction, or the reversible reaction moves towards the side where there will be lesser number of moles of gases. This is also true for the conversion of sulfur dioxide into sulfur trioxide. High pressure means higher number of moles of corrosive gases on both sides of the equation. High pressure means higher number of moles of corrosive gases on both sides of the equation. This is because equilibrium shifts to product side, then it means there will be high concentration of sulfur trioxide, and this will eventually increase the concentration of sulfur dioxide also. Both sulfur dioxide and sulfur trioxide are corrosive gases. Corrosive gases are highly toxic or harmful. SO2 and SO3 are corrosive, harmful gases. Also, we need high pressurized vessels. Low pressure means lesser number of moles or molecules of corrosive gas on both sides of the equation, or it is cheaper. Low pressure 2 atm is preferred because it is cheaper, economical. Catalyst. In contact process, vanadium 5 oxide V2O5 is used as catalyst. You know that catalyst increases the rate of reaction, but here catalyst has no effect on the position of equilibrium. Catalyst has no effect on the position of equilibrium. Because catalyst just increases the rate of reaction in both directions. So here's the summary of this video lesson. Sulfur dioxide is obtained either by burning sulfur or ores of sulfur. Oxygen is obtained through liquefaction of air. Typical conditions in the contact process are 450 degrees Celsius, 200 kilopascal or 2 atm, and a vanadium 5 oxide or V2O5 catalyst. The conversion of sulfur dioxide into sulfur trioxide is reversible and reaches to dynamic equilibrium state in a closed system. This reaction will counteract if there will be any change in either concentration, temperature, or pressure. The reaction is exothermic. It should favor low temperature, but the temperature of 450 degrees Celsius is preferred. This is because if a temperature drops too low, kinetic energy of the particles will decrease, and the rate will also decrease. Therefore, 450 degrees Celsius is a temperature compromise. Increasing the concentration of reactant will shift the equilibrium towards product side in order to decrease the concentration of reactant or increase the concentration of product. Increasing the temperature will shift the equilibrium towards the reactant side because forward reaction is exothermic or backward reaction is endothermic. Increasing the pressure will shift the equilibrium towards the product side because there are less number of moles or molecules or volumes of gases on product side or vice versa. There will be no effect of catalyst on the position of equilibrium because catalyst increases the rate of both forward and backward reactions. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.